Hi, in this example, we are going to discuss the correlation coefficient and the coefficient of determination. And we're actually going to interpret each of them. So in this example, we have the annual high temperatures in a certain location have been tracked for several years. Let X represent the year and the Y the high temperature. Based on the data shown below, calculate the correlation coefficient to 3 decimal places between X and Y. Use the numbers directly from your statistical technology. So the first thing I would do is go ahead and put this in a list where the X's are list 1 and Y's are list 2. So if you can go ahead, let's go to our calculator. You'll see I've already put this on a list, and you easily do that by going to Stat and Edit. And you can see that I have list 1 is my X and list 2 is my Y. And then the next thing we'll want to do is second quit. And if you've already done this, then feel free to forward the video. But the first thing we need to do is turn diagnostic on. So you'll want to go to the catalog, and that's going to be second 0, where you see the word catalog, blue with blue. And you'll have to go to diagnostic. So scroll down till you see the D's and just go all the way down and you'll see diagnostic on and off. So right here it says diagnostic off, diagnostic on. And again, you would only do this once. Once you do this once, you'll never have to do it again. So I would go ahead and hit diagnostic on, hit enter, and you should be at your home screen. Go ahead and hit enter one more time and hit done. So once you've done this, you don't have to ever do it again. Your diagnostic's on. So now let's go ahead and run our test. Let's get the R and the R squared. So we'll go to Stat and we'll go to Calc and run a lin reg AX plus B, which is number 4. Where my X list is list 1 and my Y list is list 2, I'll leave the frequency list empty, and my store regression equation I will also leave empty, and I'll go ahead and hit calculate. So right here is my R squared and my R, so let me go ahead and enter that in. So my R, and I would have to round to 3 decimal places, so negative 0.962, and then my R squared is 0.925. Okay, so in order to interpret the correlation coefficient, this is the strength of your correlation. So we would say that there is a strong correlation between high temperature and the year. And the next question is the relationship a positive or negative association? The association is negative, meaning as the years pass, the high temperature lowers, right? Because it's decreasing left to right or falling left to right, and therefore as years go by, that temperature is decreasing. Okay, so the coefficient of determination is a little different. It's how much the explanatory variable explains the response variable. How much of high temperature is explained by the years, right? In this case, it's a pretty high percentage. So we would say that 92.5% of high temperature is explained by the year. And then whatever's left over from the 100% in this case would be 7.5%. And that means whatever's left over, 7.5%, is explained by other factors such as climate change, nature, or we could say like weather events, and then etc. So the coefficient of determination just tells you how much the response variable is explained by the explanatory variable. How much does high temperature is explained by the year. And we would see that 92.5% of high temperature is explained by what year it is, and 7.5% is explained by other factors, which is beyond our control. And so this would be a perfect explanation for a quiz or an exam for either the correlation coefficient and coefficient of determination.